All right, let's dive right in. Today, we are getting into a fascinating medical puzzle that honestly seems to defy all logic. We're talking about a type of weakness that can actually get better with exercise. It's a really strange clue that points to an even more interesting condition. I mean, just think about that for a second. It sounds completely backward, right? Usually, when you're weak, exercise makes you weaker. But what if it was the opposite? What if a little bit of effort briefly made you stronger? Well, that paradox, that's the key, the defining clue for what we're exploring today. So, what is this thing? It's called Lambert-Eaton myasthenic syndrome, or LEMS for short. And at its very core, it's an autoimmune disorder. Now, what that means is the body's own security system, its immune system, gets all mixed up and starts attacking its own healthy cells. In the case of LEMS, it's targeting that super important communication link between our nerves and our muscles. Okay, so let's get into the nitty-gritty. To really get what goes wrong in LEMS, we first have to understand how that nerve-to-muscle signal is supposed to work when everything's running smoothly. It's actually a pretty elegant four-step dance. So a signal zips down your nerve. When it gets to the very end, it flips a switch that opens these tiny gates called voltage-gated calcium channels. Calcium then rushes in, and that rush of calcium is like hitting the send button. It tells the nerve to release a chemical messenger called acetylcholine. And that messenger just floats across a tiny gap and tells the muscle, hey, contract. It's simple, fast, and incredibly effective. But in LEMS, there's a major glitch right at step 2. The body starts making these rogue antibodies, and they specifically go after and block those calcium channels on the nerve ending, what scientists call the presynaptic terminal. So with these gates blocked, not enough calcium can get inside. That send button, it gets jammed. The nerve just can't release enough acetylcholine, the muscle never gets a strong, clear message, and the result, well, it's muscle weakness. Now, if you're listening to this and thinking, this sounds kind of familiar, you might be thinking of another, more well-known condition called myasthenia gravis. And you're right, they both cause weakness, but how they do it is totally different, and that difference is absolutely crucial. And this is where it gets really interesting. This table just lays it all out perfectly. With LEMS, the attack is presynaptic. It's on the nerve ending's send button. But with myasthenia gravis, the attack is postsynaptic. It's on the muscle's receive button. And that explains everything. It's why with LEMS, a little bit of exercise can actually force enough calcium in to get the signal through and make you stronger for a moment. But in MG, exercise just burns through the fuel and makes the weakness so much worse. So if you only remember one thing, let it be this simple analogy. LEMS is a problem with the sender. Myasthenia gravis is a problem with the receiver. It's really as simple as that. Two very different glitches in the exact same communication system. Okay, this is where the story takes a really serious turn. Because for a lot of people, LEMS isn't just about weak muscles. No, it's actually an early warning system, a red flag for something much, much bigger. Get this. In up to 60% of cases, LEMS is what's called a paraneoplastic syndrome. Now, that's a fancy term, but all it means is that the symptoms are actually being caused by an underlying cancer somewhere in the body. Most of the time, it's a specific kind called small cell lung cancer. So how on earth does that happen? Well, it's a tragic case of mistaken identity. See, the cancer cells, for whatever reason, have proteins on them that look an awful lot like those calcium channels on our nerve endings. So the immune system does its job. It creates antibodies to go fight the cancer. But then those same antibodies get confused and start attacking the healthy nerves too. It's basically a case of friendly fire. And this is why this quote is just so powerful. When a doctor diagnoses LEMS, that's not the end of the investigation. The great doctor knows that finding that first needle, the LEMS, means you absolutely must start looking for that second, more dangerous needle, the hidden cancer. So, given these really weird symptoms and this super critical connection to cancer, how do doctors actually put all the pieces together and confirm a diagnosis of LEMS? Well, it's a bit like detective work. It all starts with the hands-on clinical exam, looking for that signature weakness. Then comes a nerve test called an EMG. And this can reveal the smoking gun for LEMS, a really weak muscle signal that suddenly, dramatically gets stronger right after a tiny bit of exercise. Then a blood test can actually spot those rogue antibodies. And finally, and this is not negotiable, a scan of the chest is done to hunt for that potential underlying tumor. All right, so you've got the diagnosis. Now what do you do? The treatment plan is essentially a two-pronged attack. You've got to address the symptoms, but you also have to go after the root cause of the whole problem. First and foremost, number one priority. If there is a cancer, you treat the cancer. Period. If you can get rid of that tumor, you remove the trigger for the whole autoimmune mess. And a lot of times, the LEMS symptoms can completely disappear. Now, to manage the weakness itself, there are medicines like amphipritine that basically help prop open the few working calcium channels, boosting that signal to the muscles. And if things are really severe, doctors can use immunosuppressive therapies to just calm the whole immune system down.
And all of this brings us to one final thought. Lambert-Eaton syndrome is such a powerful reminder that in medicine, sometimes a diagnosis isn't the end of the story. Sometimes it's just the clue, the crucial clue that lets you know you've just opened the first chapter of a much larger and much more important story happening inside the body.